Hello, everyone. Welcome back to another podcast on the AI Cine series. Today, I'm really excited to have one of my colleagues, Axel, who is going to present us on a market map in infrastructure. There's a topic that we're going to talk about today that's fairly academic, but Axel has managed a number of our really large investments in this space, including our most recent investment into potentially a groundbreaking, world defining, industry defining investment into a very high profile investment. But I'll have Excel introduce himself and we'll go into the topic. Excel, thank you so much for joining us.
Thank you, Ni, for having me. Hi, everyone. I'm Axel. I'm French, based in Paris. I've been at AIC for now 3.5 years. This is my first out of university job. Actually, I got really lucky to join AIC after having completed an internship here. My background was more on the financial side, so it's been a couple of years that I'm catching up on the technical and AI roadmap. I mostly focus on the deals that we have in Europe here because we are a small team and we have a large geography to cover. But I tend also to work on other geographies as part of the deal flow.
Excel, you said that you come from the financial space, but I think that, your history is so much more interesting than that quick blurb. Tell us a little bit about, what led you to venture. And then, you studied abroad, you speak multiple languages, your history is so much deeper. So just give us a little bit more of that personal glimpse.
Sure. So when I was 9, I started playing a board game, which is called the Game of Go, which eventually led me to two things. One, to develop a strong interest about Asia, specifically about China. So I started learning Chinese when I was a kid. I went to a school where I studied economics with a focus on East Asia. And so back then I had like 6 hours of Chinese per week. Most of my classes, were having this dual comparison between the West and in Asia. This led me to go to Hong Kong for 2 years, where I did a bachelor degree at the University of Hong Kong. So that was in 2017, and that's when a company called DeepMind released a program called AlphaGo, which led to defeating like the world's best Go player, which was a Korean player called Lee Sedol. And back then I thought, okay, what the hell? Can like a robot basically defeat someone at like this game, which I've been playing for a couple of years, and I know how complicated it is. And that's what got me basically interested into AI. And so I realized that it would be hard for me, to completely change the course of my studies and go to do some engineering. So I thought, okay, let's try to approach this through the finance part. And there's many different things in finance, investment banking, private equity. None of this sounded really interesting to me. So I got the chance to do an internship in this firm. Initially, I was interested by the whole global and Asia focus, and fell in love with venture and got the chance to come back in full time.
I love that it all started with AlphaGo because recently you and I, you shared an email that I think brings it full circle. But you kind of go through that concept and you said, "Oh, how is it that a machine is able to beat like kind of like the top AlphaGo player in the world?" Tell us a little bit about that, and then tell us about that email exchange you had recently that kind of brings it a
Sure.
little bit circle.
So a couple of weeks ago, there were some rumors about the basically like the lead scientist behind AlphaGo, who's part of DeepMind, who's called David Silver, who that he had left to join a new company, and so to create his own startup, basically. So I reached out to him, and if you've watched the Netflix documentary about AlphaGo, or if you followed the news about this, there was this really particular move, which is move 37 in the game number 2, I believe, which surprised all of the Go community because this one basically move did not make any sense, from a Go professional player standpoint. The rest of the game, AlphaGo, was playing like a professional, and this game was really odd. And after AlphaGo defeated Lysidol by I think like 4-1 games, the whole community started to think a bit about okay, what did this move mean? Why was it so surprising? And what came out of this was maybe we don't need to abide by the rules that we've defined in the way you usually play Go, which is playing in the corner, trying to avoid the center, and that's the opposite of what this move was doing. It was going into the center at like the really beginning of the game, which made no sense. And so the whole community's reaction was maybe we can just like forget about all of this like hundred of years rules and try to be more creative. And this is actually quite interesting that because of an AI we actually think about being more creative. So I reached out to David on this, to try to more about this company. I got an answer, and yeah.
That's so exciting. I love this concept that, we talk a lot about training, and we'll go into the concept of infrastructure investments. And I think this is a good segue into it. But we talk a lot about kind of building the foundation models and how we train the foundation models on data. And a lot of that data is human centric. It's derived on human decisions, human biases. And I love the fact that what made AlphaGo so successful is that it kind of threw the human roles out and confused the humans. Kind of played a little bit on our weakness if we're going to think about kind of AI. The other thing I kind of want to note is that, you said, you reached out to David Silver, and a lot of times people think that, we have all of the inside knowledge, and we know so and so and so and so. I love that you reached out cold to David Silver, out with and in that email you had a picture you were replicating the game,
Yes.
and I love that. That is so creative. It's so unique. I don't think most people would think to have done that, but you did.
Yeah, I think it's an interesting one for for the people who are listening. I think people think that VC is everyone coming to you, right? But that's not actually the case, because like the best entrepreneurs, they don't need your money. Like, I mean, they can get any money that they would like. So it's up to you to actually show that you can get, like you can have value, and like like understand what they do. People sometimes say that VC is a finance job disguised in a sales job wrapped in marketing, which I think does make sense, right? If you think about it. And that's exactly here what I was doing, and David Silver, or like any researcher, they're humans. So instead of like receiving like those cold messages, hello, I work from this fund, blah blah blah, we invest this much. Try to be a bit original, like you're trying to move like the human side, basically, like the human needle.
Yes, I love it. Thank you so much for sharing that. Okay, so let's kind of spearhead into the topic at hand today. We are covering the concept of what is the market of AI infrastructure look like, and it's a big market. So thank you so much for being willing to take on such a big mission for us. When we talk about infrastructure, what the heck does that
A good point. So yeah, how can we define this? AI infra is everything which is used to train and deploy those models. So this is a really broad definition, which means a lot of different things. And the way people usually think about this, and the way like the mapping that I will present thinks about this, is how can you deploy an AI model? Well, if you think from the ground up, you need power, you need GPUs. So the first one is the compute, or like the hardware layer. That's like the first one. And you have a lot of stuff, which goes into the hardware side, which is, how do you connect the hardware to like data centers? How do you, virtualize it into a cloud? And how do you then deploy this? Then, you have this compute part, and what is going to use is going to use a model. So you have the model layer, which is the second part. We obviously have text models, but now we have different type of modalities: image, video, sound, blah, 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 etc. And then you have everything which is wrapped around the construction, or like the orchestration of these models. So the Kubernetes part, the containers part, how do you actually code this? So with the framework, we talk a lot about PyTorch, for example. And then above this, if you want to train a model, you also need data, because obviously you can't do anything without data. So you have the whole data stack, which includes different things, from storage to processing to data lineage. And the final one is the deployment part, because usually we don't deploy only one model, we can deploy several models together. We talk about systems, so we have another orchestration part here. And once the model is up and running, how do you actually govern it, and make sure that it doesn't go rogue? And this touches a bit upon the security part of the models. So that's more or less how we can think about infra, from the bottom all the way to the top part. And after this, you'll have the applications built on this, but we won't cover this today.
Thank you. I so appreciate that. The breadth is so big and so wide there. I mean, you've covered the physical infrastructure of energy, etc., around AI development and training deployment. You've covered the hardware, you've covered the software, you've covered the data stack. Before we jump into the map, we'll have you walk through that map, because you've done the research. If our students, let's say our students are watching this, and they say, you know what, I would really like to go a little bit deeper. I would like to create my own market map, let's say around data. How does one go about one either finding a market map around a topic or developing their own market?
Sure. Yeah, so that's a good question. So yeah, the easiest one is to find one which is online. You have a lot of resources which has been made. You have different types, I would say, of breeds there. You have the one which have been AI generated most of the time, or which are done, by this very generalist firms, like the CB Insights and PitchBook and all of this, which can be good, can be a good starting point. Sometimes they will meet a bit like the granularity of what we're looking for. You have a lot of this, so you type AI infra mapping, and then you find a couple of ones. VCs themselves do publish a lot about their mappings, to show a bit their thesis about a space. They also do this to sometimes get an answers from startups which won't answer them otherwise, because you show them that you're highlighting them and you ping them on LinkedIn, and that's what we're doing here today on the mapping. I will show. So that's if you want to find one which is existing. The other way, so if you want to build this from scratch, I think, yeah, you need to start. Usually what people will do is they will think about the different functions inside of like a segment. So for example, here we have compute, model, data, deploy. So that's the different like function parts, or like you think about the value chain of these parts. So you need to have a bit of like understanding of what the space is doing, and then you can break it down. And then to find the companies, then you can use the web, obviously, type for like, AI agent orchestration startup, and you find a couple. And then you have a couple of specialized database like Crunchbase, PitchBook, where you can do like a more manual work. So if you find one which is particularly relevant for, I don't know, like the routing segment, then you can look at like the competitors of this company. And so this will bring you to build like a bigger stack. And depending on what you're looking for, is it very early stage startup? Is it very late stage startups? You can use this PitchBook or Crunchbase to tailor a bit more like the companies making up the mapping.
Yeah. I appreciate, you said that one is that you can find pretty big entry level kind of maps from generalist firms such as CB Insights, etc. And CB Insights is one of those that it requires a subscription, but oftentimes they do publish these publicly available reports for the masses who don't have a subscription. Crunchbase, yeah, I love that you mentioned Crunchbase for our students here. As you're entering into your entrepreneurial journey, Crunchbase does have a free subscription tier, and you can get a lot of information from Crunchbase. I you mentioned that you start broad with these generalists, and then you go a little bit deeper with the rise of AI generated content. How do you assess what's like a good map versus what's not such a good map?
That's a good point. I would say that in my experience, I've relied a lot when I'm searching for existing maps. I'm relying on what other VCs have been doing. If it's coming from like the website of one VC, if it's coming from the Substack or like Medium, which is like where people usually do their blogs, a page of like one VC or like a fund that I know of, that I respect the thesis, then it kind of like pass my threshold for validity. And it's true that otherwise, yeah, you do have a lot of like slop on the internet, and that's why I think tailoring a bit your sources is important. And you can definitely like ask like a Perplexity or like a Claude or like ChatGPT. Just focus on strong sources, which could be like the following ones. It's also one way to do it.
Yeah. I deeply appreciate just making sure that, to emphasize for our students who are listening, that you need to validate the source of the information that's coming from. So for example, if you're going to look at an AI infrastructure map and it comes from one of the powerhouses in AI infrastructure, such as, let's say, Intel, et cetera. I mean, these all have venture arms. Then you're more likely to be able to trust that data because they spend morning and night, day in, day out on that topic, and so they're less likely to put out slop than somebody who does. Yeah. Great. So let's jump into the map. Let's if you want to present your screen, please let us know. If not, we can overlay it later.
Let me try to share this. Okay, here we go. All right. Can you see the screen?
Yes. Okay. So tell us, start with why this particular map.
Yeah.
How you found it, and then where do we start? And if it's okay, I know this topic. We at AIC, Alpha Intelligence Capital, AIC, the fund that Axel and I work at, we invest across this entire stack. but our students don't know this. So if there's certain things that you mentioned that is you presume to be kind of industry standard, but our students might not be familiar with it, I will ask you to deep dive a little bit, or at least explain what that concept means.
Sure, of course. So how did I find it? Yeah, as I said before, I looked on one of the AI generated search space. Well, I knew of this fund, which is called Activant Capital. I knew that they tend to publish a lot of good research. And I remember that I had seen a map in this space. So I went to their website. They have this whole like research area, which was like a whole focus on AI infra, which is like 4 different papers. And, they started this with this mapping that I found was super good because, it went all the way down to all the way up. It mixes incumbents. So you see, NVIDIA, MongoDB, Databricks with, like some earlier stage startups. It is US centric, but most of the companies are in the US, but you also have some European players I see there, and quite early stage for some of them. So I thought that it was quite relevant, and I liked how the segmentation was done. So you had like a good level of granularity, among each of these different layers.
Mm-hmm. Great.
And so, yeah, so what can we, if we start, from the bottom up, why did I like this, and what were my thoughts basically when I saw this? So on the compute side, obviously we have NVIDIA here, which is like the big player. We know this. I appreciated that they added a couple of like the challengers that we have this: AMD, Intel, Cerebras, Groq, SambaNova, Mythic. It got me thinking was that, yeah, we were starting to see more and more players coming from this. You have this lock-in in NVIDIA because of their software layer, which is CUDA. But you're starting to see some new players, either among the established big guys, so AMD and Intel. AMD here has like deserves its place as like the second player, I would say, because like they are the very credible challenger to NVIDIA, where Intel has been a bit more disappointing. And then you see all of this custom silicon with Groq, SambaNova, which show that these specialized architectures, they deserve like a seat at the table. And it's not a surprise that Groq was acquired by NVIDIA a couple of weeks ago for $22 billion. So you have this first part. On the networking, I think it's a really interesting one, which is how do you run this flow of data into the data center. This is a space which I think is super interesting. We're talking a lot about photonics-based interconnect because you have the scale of the data that you're moving is so huge that now the bottleneck is not only in the chip, it's in the movement part. How to move them between the chips. So that's why I appreciated that they moved, this that they showed this part. Moving on a bit.
Before we move on to that, I love what you mentioned about the AI accelerators, and I think if you look in on the compute layer for AI accelerators alone, there's significantly less logos than what you see in some of these other stacks. And you did mention that NVIDIA acquired Groq. There was for about a year back, the Intel was rumored to be in discussion to acquire SambaNova. And so really, if you start thinking about it, there really aren't a whole lot of players in the AI accelerator part of the stack. Why not?
Why not? That's a good question. Well, the first question, the first answer is the money that you actually need to build basically like those chips. To do like a first tape out of those chips cost like dozens of millions. Not everyone can raise this money, I would say. Not everyone have the experience to also build those chips. And I'm assuming that most of the people which work at NVIDIA have become millionaires over the past years, and like the incentive to live in NVIDIA has been reduced over the past years. That being said, I think that if we were to compare this map in like 1 or 2 years, we will see a lot of new players. Over the past months, you've been a lot of new companies building inference chips. So really focused on inference, because I think that on the training side, NVIDIA has a massive moat that will take a lot of time to be challenged. But you will see a lot more coming. There was one over the weekend that I will try to find you the names afterwards, which just tape out its first chip, which is an interesting one since it's basically like the model, which is a Llama meta model, is hardwired directly into the chip, so it's only running this model, but it is, I forgot if it's 100 or 1,000 times faster in terms of throughput than an NVIDIA chips. So you're going to see a lot more of these new specialized inference chips, which is going to create some interesting opportunities on how do you orchestrate between different chips for different type of architectures and different type of models.
Yep. I deeply appreciate that. And, I want to mention that to our students because, the students who are going through this course, they tend to be upper level undergrads. And oftentimes, they see something that's very interesting and they say, we're going to pursue it. And so for students, if you are interested in the compute part of this stack, just know that it is capital intensive, it is labor intensive, not to discourage you from pursuing it, but to set kind of your sights on this. If you are going to go into it, you keep your eyes wide open to know that while there are emerging players, the road to getting enough researchers to adopt your tech, your hardware is long. So you have to be prepared for it.
Yeah, absolutely.
Okay, let's continue.
Sure. So then, moving a bit to the cloud providers. So once you have the compute, how do you do like how do you virtualize this, to be able to use a model and to deploy it on top of this? Obviously, like the three main players we have are AWS, Google, and Microsoft in this order, because AWS is like the main player of this market. I think they have around 70% of the market. But Google has been doing some interesting stuff, and Microsoft is a bit behind. What is interesting here, and that we would not have seen, I would say, pre-Gen AI or like even like 2 years ago, is this neoclouds part. So what are these neoclouds? So most of these players started during the crypto area. So they bought a lot of GPUs from NVIDIA, and they were using this for mining Bitcoins. Since like the demand for Bitcoin has been a bit on and off for a couple of years, when Gen AI came, and if you remember at the beginning of ChatGPT, we talked a lot about this shortage of GPUs. A lot of these neoclouds, like they used the GPUs that they had from back then to provide this compute power to the applicative layer, or like the model makers. What is interesting is that they started as resellers, I would say, of GPUs. And here the main player is called CoreWeave. It's an American company. They IPO'd a bit earlier this year. And so what started from like a pure infrastructure play, so only reselling the GPUs, usually at like a relatively cheap price, they've moved a bit and they're starting to become really interesting players on the software side. So they're developing all of the stack to actually orchestrate, even build sometimes those models. They're not so much playing on the data side, but they're really touching upon like the right part here. So the serverless inference part, the container and orchestrations, and even now the routing or like orchestration at the deployment layers. And so there's going to be a lot of interesting things coming from this space, because as the hyperscalers are now vertically integrated in the way that they don't only provide the cloud, but they provide many different solutions, the neoclouds are starting to do the exact same.
I deeply appreciate that because, what you mentioned about, I'm going to jump backwards a little bit on the compute hardware side. There aren't that many AI accelerated providers. And on the hardware side, there was a period of time in 22, 23, there was a chip shortage. And so when we're moving into these concepts of like the cloud providers, hyperscalers are big, obviously, and they have a massive amount of compute. And for example, AWS has their own hardware that they sometimes use in addition to NVIDIA and AMD and Intel hardware that they have in their servers. But it is expensive. It's expensive. And so I deeply appreciate kind of the rise of what you, have kind of told us is the origin of it. Is some of it comes from the crypto space, where a lot of people who are mining for cryptocurrency had their own GPUs to begin with. And because of that shortage, they saw the opportunity to be able to allocate and orchestrate the access to some of these smaller compute resources, and it became, the neo clouds, and then it started moving into kind of more of these marketplaces on what you're looking at on the right hand side here.
And just one interesting point on those guys. So what they've done really well is, they've gathered a lot of demand from, the OpenAI, Anthropic, like all of the model makers, or like the second tier model makers who could not get access to the latest GPUs with AWS, Google, or Microsoft, Mistral, for example, all of this. They've done this at the expense of a lot of debt, because to fund this GPUs, to fund this compute power, they had to build data centers, for example. And if you look, for example, CoreWeave, into their earning statements, the debt ratio that they have is huge, but people, are still ready to give them money because, they have such high growth. And that's for this reason as well, that now they're trying to move more to the software side, which, requires a bit less capital, has a higher margin, and, they believe that with this, they would be able to compete with the hyperscalers. Another player which is interesting, and since our listeners are from Kazakhstan, they might be familiar with Nebius, which used to be called Yandex, which was the Russian Google, basically. At the time of the war with Ukraine, they spun out and they became an independent entity, which is based in the Netherlands now. And they are doing a really interesting work, have an amazing team coming from Yandex. They've been doing infra for 20 years, basically. So they know how to build those systems, build the racks, and they have pretty good unit economics if you compare them to a CoreWeave or like a Lambda or Crusoe.
Great. Thank you for that additional context. I know you mentioned at the beginning a lot of this map is US and Europe centric, and I do appreciate being able to see something that is a little bit outside of those core two markets. On that point, why is so much of this part of the stack US and Europe centric?
Good point. Well, that's where the most money for funding from VCs have been, I would say, first of all. More than this, this almost doesn't look like software funding, because it's mostly not software. It is almost becoming an infrastructure. So we're talking private equity, like big, huge like investment funds with like billion who can invest, hundreds of millions, and most of them are actually more into Europe and into US mostly. I would say this is one reason. Maybe on the energy side, there is more efforts being done for now in Europe and in the US on this front. Doesn't mean that I think that there's actually more energy capabilities in Asia, for example, but just like the whole infrastructure of this has not been fully developed, because it actually takes time to connect the grid and to build a data center. But I think we'll see a lot of interesting stuff coming from more emerging markets in the coming years, fueled by renewable power, for example, but it takes a bit of time. So this will come because every region now needs to have their own data center and their own compute. At the time and the money that you need to invest to get this takes a bit of time.
I thank you for sharing that.
What do you think,
Kazakhstan is on the border of China, right? So, and I know that, a while back you had a thesis around what does the rise of AI in China and how does China's role in the AI space evolve? And what we're starting to see is China is heavily investing in energy infrastructure and building their own chips. Part of it because of the political kind of politically charged revocation of access to compute hardware from the US. And so, given your strong understanding of the Chinese market and your strong understanding of the AI market, can you also kind of tell us a little bit about, what does the rise of this compute layer development look like and when does China start to emerge as a strong player?
Yeah. What China has been doing on the compute side is quite interesting. So most of the biggest cities in China are on the eastern side, so Shanghai, all around the border with the sea. So what they're starting to do is build data center not in the east but in the west part, which have less habitants, have really more space, have a lot of like wind or like sun, and so they're starting to build like those mega clusters. But again, it is taking a bit of time. But there is this whole focus, on becoming independent from the rest of the world, on building their own chips and having their own data centers. There is not that much that we do get, from their plans on this objective, but it is clear that it is now like the main focus of like the next 5 years, because they use 5 years plan, and so this will be more and more interesting. On the chip side, they've started to develop their own accelerators. Huawei, Hungry Corn, there's a couple of names. It seems that Western analysts thought that China was like, I think it was 3 to 5 years behind. It seems that like this window is closing. It's actually now like 2 to 3 years tops, basically.
I think, I love that you put the time context into this, because, as our students are building out in their AI startups, they don't have the constraint that they can't use Chinese hardware, software, etc. And so, students, as you're going out there and you're building, make sure that you're looking to providers in the West and the East of you, because you have an emerging superpower who in major player in the AI space that isn't currently at this point isn't on a lot of these infrastructure market maps, but will be within the next 2+ years, as Excel mentioned.
Absolutely right. Yeah, correct.
Okay, so now we've covered the hardware layer, and I know that very superficial view. And students, as Excel mentioned earlier in this podcast, if you are interested in any of these particular areas, you can always deep dive and build your own particular market map in around any of these smaller boxes within this bigger map. But let's move towards more of, we've talked about the hardware. Let's move towards the software side.
Sure. So moving a bit, above. So on the model side, so obviously here you have a lot of different players. So on the foundation models, which are either only text, either image, audio, code, or purely multimodal. So we have a lot of different players. Again, here, most of these players that you see have been really well funded, because it is super expensive to actually build those models. So we're talking, like hundreds of like millions to do like a single run. So that's why you see like the OpenAI, Anthropic, Google, Meta, Alibaba with Qwen. Coming back to China, it is interesting that here we have 1, 2, 3, 4. I'm counting like the Chinese players. So we see Tencent, we see O1, we see DeepSeek, and we see Alibaba, right? So you have more and more of these players which are coming, from Asia. And so here, like the biggest tension, I would say, that we see on the foundation models, and it could have been actually classified as such, is who is doing open source and who is doing closed source. Over the past years, we've seen most of the players, even OpenAI, which was like one of the last ones who had not done any open stuff, releasing an open source model, which is now quite useful. And this was interestingly pushed by the release of DeepSeek, the Chinese model, which had really, really strong performance, and which was an open model. On the
Now, before we move on from that concept,
Yeah.
our briefly, and our students are in the advanced AI portion of the course, so they know what open source versus closed source is. But can you just, for some of these model providers who have both open source and closed proprietary models, what is the incentive to release an open source model and then maintain a separate product that is closed?
Sure. I would say that for OpenAI, at least, it was mostly like a strategic response, right, to China. What we saw over the past year was that most of the US or like Western developers were starting to build on Chinese models, and this for the federal government or for like the higher government part is a risk to have everyone build on non-national basically models. And so you had like this whole pressure to start releasing your own type of models. And we do see as well this coming into the US. Now we have pure open source foundation models company being funded and starting to release their own model. There is one in the US called Reflection AI, I believe, which is in this front. And I think, so you have this one, so national security. The other one is, most developers, like open source, because that's what they can use. And so if you want to get, like the developers to actually like you, and enjoy what you do, open source is a good strategy to get closer to the developers.
Yeah, I thank you for that. In what you said about the security is affiliated with it, I think there's also the other element of it, which is national models have different data, right? Every model has different data is trained on it. And so, for example, Kazakhstan has a model that they developed with a major university in the Middle East, and that is trained on Kazakh language. And Kazakh language is a low resource language in typical Western centric foundation model countries. And so I think, there's the security aspect of it, and then there's the performance aspect of it for each
Right.
and so
Absolutely.
students, as you're going out and let's pretend that you develop at the application layer and you want to rely on a foundation model provider. Just be careful as to which foundation model provider you're using to understand what is the underlying data that they're training and developing that model on. Because, for example, if you're going to use it for something that requires Kazakh language understanding, then just know that you might not be able to find that from a US centric smaller model provider, but you might be able to find it from, let's say, somebody who's developing it in collaboration with Kazakhstan.
Yeah, absolutely.
And then just a quick plug for us and for our firm and for the students here and kind of Kazakh national pride. We talk about foundation model companies as if that's the only thing they do, but we at AIC, we've invested at the foundation model layer, but we've also invested in companies. For example, one of our portfolio companies comes out of Kazakhstan that spans, they have their own foundation model, and then they also have kind of the application layer. Can you just help us, given that context, can you just help us understand why someone would choose to just do foundation models? And are foundation model companies truly just only doing foundation model and not doing something at the application layer?
Good question. So at the early beginnings of 2023, we saw all of these companies starting to release only foundation models, so OpenAI, Anthropic, Mistral, etc. What we've started to see, over the past few months, is that running those models is expensive, training them is expensive, and even when and the inference of it is actually, expensive, specifically when you are on a B2C setting. So you're mostly using ChatGPT, for example. The margin that OpenAI gets when you use it is not that high, right? So that's why we're starting to see more players which are thinking, okay, maybe it doesn't actually make sense for me to build the model. Maybe I should just use what others, are doing and try, to package it into something a bit bigger, into a platform where you can use different models and build like an application out of this. And that's what we're starting to see. So even, even the model players themselves are starting to do so. So we're seeing OpenAI, which is releasing some product in the medical space, for example. They're also releasing some device which can listen and hear you all the time. We've seen, on the coding space, we've seen the rise of vibe coding, which is allowing you to build an app basically by using this foundation models. So I think we're now moving more towards the area of building apps more than building these models, because we're seeing a lot of commoditization at the model layer and commoditization more at the bottom. So it's starting to become a war on the price side, and the money is actually more on the applicative side, because if you have a really useful app, you have a better pricing power, and you can charge your user for a premium basically.
Yeah. That makes a lot of sense. And I know that there's a number of logos on here right now, and this space is moving so fast. I mean, there's a number of other players that are on here. So for example, Higgsfield, one of our portfolio companies, is a Kazakh company, and your students here have heard that name mentioned multiple different times in multiple different contexts, and they'll hear it again. But Higgsfield is not on here, and we don't list them as a foundation model company because while they do provide access via API access to their own underlying video foundation model, they are not fundamentally, the business model is not a foundation model company. And then the other one that's not on here is that we recently invested in a company that came out that was founded by one of the godfathers of AI, Jan LeCun, and it's not listed on here. So this space, Ami Labs, is founded by Jan LeCun. He is the former chief AI scientist at Facebook, Meta. I apologize, Meta, and it's not listed on here. So this space is evolving very quickly, despite the fact that these models are starting to be commoditized.
Absolutely.
Okay, so we've covered foundation models. Let's move on to kind of the core software part of this.
Yeah. So I think what is the most interesting here is the framework and the MLOps part. So the framework, is framework is basically how you code basically like those models. How do you actually use them and code them to deploy them into production? Two players here, which are interesting. So PyTorch, which is an open source solution released by Meta, and TensorFlow, which comes from Google. The one which has mostly won, I would say, on the GenAI wave is PyTorch. So the vast majority of developers are using PyTorch, which is much more native for LLM functions and tooling. So that's like the main one that people are using now. And we see this, being used on top of MLOps, which is DevOps for machine learning. We now more and more talk not about MLOps, but LLM ops, because this is applied to the specificities of ML models. And so this covers, all of the experiment tracking, so logging which models, the versioning of the data sets, and it's prepares it for the deployment side, which we'll see a bit later. How to monitor the performance, how to retrain them, when needed. So this is all of the plumbing that you use behind this. The biggest player is weight and biases. And coming back to our points about NeoClouds, weight and biases were acquired by CoreWeave in the mid of last year for above 1 billion, if I remember correctly. So you have a lot of movement in this space, and it's starting to become like a core acquisition targets for some of the lower players here, I would say.
The same question for when we talked about the hardware side of this. Why in the AI ML frameworks portion of this, why are there only two major players?
I think that on this one, it is because by nature the framework was free or very short of not expensive basically. So you don't have like a whole lot of players which can actually do this for free to the scale that this requires. And so here this was sponsored, I would say, by Meta and Google, so two really big players. And the idea behind this was that if you can have people build more on your stack, basically like can get more users, more data, and this gets to like some network effects for the long term, both on the hardware and on the application side.
Yeah. I love what you said about the network effect, because one other amplified part of the network effect is because Google and Meta can afford to do this for free at a loss for a number of years until there was significant viral uptick that you could get the network effect that a number of developers are developing on it. Once that happens, new and emerging companies really have a difficult time getting into that because of the strong foothold. Because if you imagine, let's say our students are coming out and they are coming out of school, they're not going to choose someone else to use. They would like to continue to use AI/ML frameworks that currently exist, because then they would be able to collaborate with developers that develop on top of that stack. Whereas if you're going to pick something new or novel or non-obvious, when and if necessary that you need to collaborate or integrate, it would be a little bit more challenging. Yeah. Okay. And then on MLOps, can we just talk a little bit about what's covered under MLOps?
Yeah, sure. So all of the idea of MLOps, is the end-to-end, like the full life cycle of a machine learning models from the development to the production. So it is, to some extent, it touches upon the data and the deploy layers of this. We put this because like they're the ones sitting the closest to the model side, basically. And so here you're gonna get the tracking of the experiment, so which model configuration, which hyperparameters worked. You will, on this setup, the training infrastructure. So this is linking to the compute layer. You're going to get like the versioning of the different data sets, and you'll be able to deploy this in production once this is deployed, to monitor the performance. So if you have some drift, you will be made aware of this, how to actually retrain this whenever it is needed. And that's why, it is like they put this here, but we could a bit challenges in the way that it also touches a bit upon the observability part that we see at the top part of this. But all of this on the above side are like really new layers, and MLOps has been here, for years, because even before LLM, you already needed to do this observation part, basically.
Yep, I see. So then in And in MLOps, it's the tooling necessary to take a foundation model and fine tune it, retrain it, etc.
And deploy it.
And deploy it, yes. And then so there's an element here that we've talked about, which is which we haven't covered, is containers and orchestration. What does that mean, and where does that?
Yeah. So on the container and organization is more related to the cloud side of this. So how do you actually, orchestrate your model and your application in different pods, which are, these containers parts, to make sure that, it is the most efficient possible to run, and that, it's not too expensive, that, there is also some security concern out of this. So the main one that we do see in this space is Anyscale, which has become, the de facto framework for distributed computing, because when you run this model, it's not going to run only on one GPU, or you need to orchestrate across different GPUs, because GPUs are really good at doing things in parallel. So you can use this to make sure that the GPUs do not sit idle. Meaning that they don't do anything. So you use these frameworks for the training and the deployment, the inference of this model. So if you were training, anything at scale, you're mostly using Anyscale, and the framework that they have is called Ray.
Thank you for covering that. I deeply appreciate you kind of pointing out the major players here. If we'll take kind of one level and one step back to kind of a little bit more of a beginner level. Students, Axel mentioned that, when we go from the hardware to the cloud providers earlier, we said that, we can't always run things on your hardware. The concept of containerization is, if you think about all of the processes that you would run on one GPU, how do you port some of that or all of that into another GPU? And so let's pretend that, you're talking about this concept called on-premise. So if on-premise means that you're truly running it on your local network. So if you have enough GPUs, you could orchestrate across those different GPUs and not run on a singular GPU, but to even kind of port enough of your processes and your applications so that you can kind of package them. Packaging them is what we call containerization. So if you package it so that you can run it across the different GPUs that you have, that's the idea of containerization. And orchestration is this concept that you are able to kind of simultaneously project manage across the different GPUs that you have and the different parts of your processes that are running on each of those. And so now we've talked about on-premise, but then if we start moving into, let's say, you want to run it in the cloud, because maybe, let's say, you don't have enough of your own hardware, or let's say you have, let's say, I don't know, 500 GPUs, but this job needs, 1,000, 2,000 GPUs. You could do a combination of on-premise and cloud hybrid. And for that, then the containerization and the orchestration becomes a lot.
Yeah.
Okay, so we've talked about the compute layer, we've talked about the model layer. Let's move on. Then we talk a lot about data. I mean, data gets mentioned all the time. And so, where does data come into play, and what does that mean?
Yeah, sure. So, as we say, garbage in, garbage out. So you always need to make sure that you have a lot of good data. So obviously, once when you train those models, you need to have have and memory, right? So here we're not going to talk so much about the two left layers, so operational and analytical storage. This I've been here for. These are classic databases which use so Snowflake, Postgres, the most popular one. One which is interesting, I think, here is the vector database one, which we see here. So Pinecone, Qdrant, or most of the big players. So this did not exist before 2022. This exploded with GenAI. So what they do is they store the embeddings. So an embeddings is the representation of a text or an image or other data. And this allows you after to do similarity search, which is the core of RAG, retrieval augmented generation. And so when you want to use an LLM to answer a question about your internal documentations, vector databases are what this makes it possible. So you have a lot of players here which pop up. Basically 2022 to 2024. It's starting to become a bit crowded. We're starting to see a bit of acquisition. This was an interesting sector which got a lot of funding back then. And so Another one, which is interesting and is quite new, I would say, basically in this space, is the unstructured data part. So we see more and more non-text models. So we've talked a bit about the audio, like the video one, or like PDF as well, for example. All of these are unstructured data. So how can you handle those data? How can you store them? How can you get like the best presentation out of them? This is going to be done by this type of solution. So Voyage AI is an interesting one. And if I'm not mistaken, they were acquired quite fast actually by Databricks or Datadog. That's it.
Well,
A final,
so
yeah,
on that concept, can you just talk a little bit about what does structured versus unstructured data mean, and what does that mean in the context of training a foundation model?
sure. Structured data is mostly going to be, anything in a table format. So anything we know which is going to be into row and columns. So spreadsheets, databases, CRM records. So it has a kind of like defined format. Unstructured data is everything else. So document, PDF, images, video, audio. So it doesn't have like this predefined schema. And so that's what you are handling a lot when it comes to LLM. And so traditional databases, were struggling to index, and query those documents. They could only do this mostly for like a clean spreadsheet. And when it comes now to LLM, so most of the enterprise data that is now using is unstructured. And before it used to be like hard to actually use this, and that's why people were spending so much time, to structure and to clean the data in a structured way. And now with LLMs and GPTs, which are really good at handling those data, you can now read, summarize, reason over this data, and that's why RAG pipelines and vector databases and this embeddings model came out basically.
One other thing to also mention for our students here is that we are under we're under the perception that all data is good data, and going back to what Excel said is that garbage in, garbage out. So if your data, if you are using a model that requires more of a structured data kind of database, and you kind of feed in unstructured data but have no way to be able to process that into something that is processable and observable, then it's truly, even if you have quality unstructured data but no way to process it, then that's still considered garbage in, garbage out. The other thing to understand is in this space, we've tapped into a lot of structured data. Now we're starting to see that there's in antiquated industries, or industries that we typically don't think of as valuable for data. So for example, mining, oil and gas, even some healthcare data is very difficult to kind of understand. We're now starting to be able to, with these tools that are help us process unstructured data, we're now being able to derive value from that data and enter into new market opportunities that really didn't exist before. Okay, let's continue.
Yeah, on the right side parts on the operation, I think the one which is interesting to touch upon is on the metadata and lineage part. So what are metadata? So it's essentially data about your data. So you have a data set, you want to know what the columns means, who owns them, when was this updated. So it's like a library, like a catalog for your data basically. And the idea of lineage is how to trace the flow of data through different systems. If it gets wrong into a dashboard, how can you trace it back to when it was transformed and where it broke basically? This is really important in the context of LLM, because that LLM hallucinates and give wrong answers. So you need to be able to trace it back and understand what data was fed. This is still a work in progress, which is taking a bit of time. This is an interesting space that we at AIC have looked a lot into and are trying to understand a bit better. But because we think that this can have some really interesting ROI when it comes to enterprise.
I deeply appreciate what you mentioned about tracing the lineage of the data, because AIC has invested in a company that comes out of Israel that does what's called unlearning, and so we talk a lot about machine learning, but we don't talk about the unlearning element of it. And so can you just explain a little bit about what does learning mean in the context of what happens to a foundation model, and then why you would need to trace the lineage and then unlearn certain pieces of data?
Sure. So what is learning? Learning is, so you fed the model like a lot of different data, and it's going basically to learn out of this representation of what you've shown to it. And sometimes the data that you have given maybe is it's wrong, is outdated, you want to change it, or just it just understood something which is not correct. And so because LLMs are designed by default basically like to please its customers and to maximize like function, they tend to say things which are like don't make any sense, right? So that's where we have some hallucinations. So the idea of this company is that if you can actually pinpoint right into the data of the model what went wrong, which data influenced in a bad way the decision made by this model, and you can erase this data without having to retrain the whole model, which is normally the way it's done. So if you want to remove some data from the data set, you need to actually remove all of it and retrain by excluding this data part. So how can you do this at like a fraction of the cost? And so you can unlearn like the bias, unlearn like a wrong data. So imagine you train for like a cancer or like disease detection, and the data set said that this person had cancer, but actually it was wrong. So in this case, how can you automatically in like one click remove this data set from the training data without having to burn more GPUs to retrain the whole model? That's like the main focus of the work.
I deeply appreciate the coverage of that improving the performance. Students, if you're thinking about using data, the learning part of it is learning the data, learning the patterns of that data, and then using that pattern to be able to kind of perform in a specific task. So, in higher context, let's pretend that you've learned how to do, I don't know, play football. Let's say you've learned how to play a model that is very good at evaluating football, but now you want to be able to play cricket. Right, those are two fundamentally different games, and so maybe like what would cause a penalty in football doesn't entirely cause a penalty in cricket, and so forth. And so it one option is you start from scratch and you brute force retrain the entire model, but some of those concepts in cricket and football are somewhat related, right? Into the concept of scoring, etc. So maybe what instead you do is using, for example, the company that we've invested in at AIC, Horundo, you can use Horundo to identify what data in the rules of football tie back to which part of your model branches and the weight, and then selectively unlearn those parts that skew you too far from the performance of cricket, for example, and then retrain those particular portions of your model with cricket rules instead of football rules. Okay, so we've talked about this area. Governance, I know that we talk a little bit more about that up on the deploy layer. So I if we can, let's move into the deploy layer and I'll ask you a number of questions about quality monitoring and governance.
Sure, yeah. Maybe just quickly on the deploy part, I think like this first layer is an interesting one because these are pretty new to LLM. So the routing, the orchestration, and the prompt engineering part. I think those are relatively recent. And what they tell us is that what is routing? You now have multiple models, multiple LLMs. Each of them, are quite good. They have different size and different cost. The idea of routing, which is embodied by these two companies, which are like mostly like the main ones, is how to route your prompt, so your input, what you're telling the LLM, to the best model for this specific task. So most of the developers are using multiple LLMs, so GPT, Claude, Mistral, or open source one. And so the router is going to send those queries to whichever model is the cheapest, the fastest, or the most able to complete basically this task. And it doesn't matter because the costs change a lot from one model to the other. You might not need a super big reasoning model if you're asking a super easy questions. And so the idea behind routing is how to cut the inference cost while maintaining the quality part. So this is now becoming like one of the core stack of the developer. Sorry, and we can see this as well, in line with the orchestration, which is now that you want to build LLM apps. It's not only one model, right? You do different things. you have multiple steps. So you're first going to retrieve the documents from the vector database that we see here. So the orchestration will call the vector database, try to understand what is going on, and then it will use the prompt that is given to call the model, call an external tool, for example, if it has to do some web search, and this becomes the idea of like systems, and that's how most people build. Longchain is like the most well-known player in this space. LlamaIndex was also an important one, which is more focused on the retrieval side. And so it's a LLM application now. It's not only like one model, it's different tools wrapped up together. And for this, you need this orchestration layer, which is becoming super important. And the final one that I think deserves a bit of talk about is prompt engineering and fine-tuning part. Whenever you talk to an LLM, so you do a prompt, there is an optimal way, I would say, to do the prompt, specifically, when you are using it in an enterprise. Now people are building libraries of prompts so that you can, test, manage the different prompts that you've written, just as if you were, writing code, basically. And so to make sure that you have the same logic, the same rigor, people are using these solutions, which will provide with you the storage and will also give you like the memory basically of the different prompts that you used before. And it touches a bit upon the idea of fine-tuning, which is how to take a big model and train it on specific company data, for example. You don't always need, again, like a huge model when you want to do like a narrow task. And so we're using this fine-tuning solution to tailor a smaller and cheaper model to the task that we're trying to solve.
I want to highlight something that you said there. You said that you're not always going to use the biggest model. You're not going to always use the most expensive model. And obviously, people optimize for cheaper. But I think that, in life, as in models, you can either be fast, you can either be cheap, or you can be performant. You can't be all three. And so, on what you said about routing and prompt engineering and fine tuning, I want to go back to something that you said. We've mentioned the context of LLMs a lot. So we're starting to see the rise of models that are not language-based. They are not large language models. We're getting people that pitch to us on a regular basis, small language models, video models, et cetera, et cetera. And so students, as you are building your own AI company, oftentimes a lot of these application layer companies have their own proprietary model and they use external models. Let's say, for example, Higgsfield, Higgsfield has their own video model, but they don't develop their own large language model. A lot of that is open source data that open source models that they've kind of modified for their own use. So, consider that you have the ability to tap into a number of models, but you do have to, one, select the appropriate model for whatever the task is that you're doing. And so that's tied to routing. Orchestrate across these models, so, figure out how to relay parts of your prompt to a video model versus a language model, etc. And then when you're doing the prompt, when you submit a prompt from the user interface side, it seems pretty straightforward. A lot of the times that is either video, that is either written language or spoken language. But orchestrating and identifying which part of that prompt gets sent to which model, that becomes really important. So as you're developing it, think of it from your user experience side as well as from the development side. Okay, so we've talked about that. You saved optimization, and and that's this part of the deploy layer. And I see a logo on there that I'm very excited about. So tell me a little bit about what does optimization mean? And then I'm looking at a logo. I'm hoping that you're looking at the same logo.
Yes, I am. And I was actually a bit surprised that they would put it here, to be honest. No, yes, so the idea of this one is how to make the models run faster and cheaper, basically, in production. So that's the whole idea. So the two main names here to be mentioned. So VLLM, which has become, like the main framework for efficient LLM inference. So it uses basically a lot of techniques which are going to reduce the GPU memory utilization and the throughput. So this is widely used by the developers. And another interesting one, that I think you were hinting me towards is called Modular. It's a company of which we're now shareholder, which is taking this a bit of step further, which is you need to optimize obviously on the memory, on the GPU memory, but since you're now going to get different types of GPU, different types of chips. So we talked about NVIDIA, AMD, Intel, Grok. All of this, have different memory constraints and memory utilizations. So how can you try to run the inference side at a higher level and to work this across different chips without having to taking into account the specific details of each of those chips, because all of those chips have their different software that they're using to communicate with the developers, and all of them are different, and like not all of the developers like this languages which are like lower level type of languages. It's like less native basically. So how can you use solution like modular, which is abstracting all of these difficulties to optimize the deployment of those models across different chips?
I'm glad that you were looking at the same. And students, when we say shareholder, that means we're an investor. Okay, so last but not least, monitoring and operation.
Yeah. So that's where it gets a bit. Sometimes what we've seen is in MLOps, and in observability can touch a bit upon. So monitoring. So this is mostly for once you've deployed the models, right? Which is different from MLOps, where it's mostly when you are training them, right? So we see a lot of players here, because this has become like a really crowded space. What this part of observability and evaluation is going to cover is what prompt went in, what went out, how long it took, how much it cost, and whether the answer that it gave was good or was not good. So this last part, of assessing whether it's good or not, it's called the evaluation, and it's one of the hardest piece of software developments, and specifically for LLM. So how can you give a confident, well-formatted answer and be able to judge this afterwards? We see a couple of players here. So Arise, Longsmith are two of the most used ones, and and you also have like some incumbents. Datadog is like a name that you might recognize from before, which is now doing a big turn on the LLM area, versus all of the other players, which I would say are more LLM native, basically.
And then on something that's not covered here is on more of the open source community source side of it for benchmarking. There's LM Arena, and that a lot of people will see here. And so if you're in developing your own foundation models or your own application specific foundation models, just know that their LM Arena is one. It's kind of like a community source leaderboard where they kind of give you specific tasks and that you have to perform, and then you submit the data that you use, the task result for you running that task, and then they kind of evaluate, and then you get ranked as like a top leader, or however you want to score on that leaderboard.
Yeah, and we see a lot of players. So I think this tells us two things. Which is that it's a big problem basically for enterprise. So every company that who deploy LLM that they want to know whether those models are working well, and no one has won yet apparently, which also means that the barriers to entry is relatively low. So it is less expensive to build something in this space than to build a chip, among others. It is obviously like a difficult issue, but it's not as difficult, I would say, as building a chip or like building like a foundation models. So that's why you see so many players. It's a space that we're looking into, I would say, at AIC. We're trying to find solutions which are more focused on the now that we're not only talking about one model, but like agents, so like a couple of models stacked together. How can you look at this from like the whole agent perspective? How can you understand the behavior of the agents? And we start to see a bit of research on this, but nothing which is put into production yet.
On that side, students, as Excel said, it's easier to enter into this space because it's not as expensive, but it's harder to be able to win this space because one is that when you talk about evaluation performance, every enterprise, every company uses AI models for a different purpose. They have different usage behaviors. They have different users. And within an enterprise operations, a lot of enterprises don't truly know how to evaluate, what specific tasks they're evaluating for, their evaluation protocols, etc. So that space is still to be defined. there's not a really clear consensus on how organizations are supposed to evaluate the performance of the AI stack that they're using. So just know, if you do enter in that space, yes, it is not as expensive in terms of capital investment as hardware, but the consumers are still trying to figure it out. And so it's a little bit of a nebulous space because your consumers don't really have a clear understanding of what their needs are. Okay, last but not least, governance. So we see governance twice on this map. What is governance?
Yeah, sure. So the governance and the security part. So you've always had security for ML models, right? Both security and governance. So governance, I think here is more in the terms of like compliance, how to make sure that this fits like the security regulations that are in place. What is interesting is with LLM, the attack or like the threat surface is becoming like wider. So there is new ways to actually attack those softwares. We talked a lot about prompt injection, which is basically like how to trick the model into ignoring its instruction, how to prompt the model in a way that it will leak its training or like sensitive data. And you have different types of attacks, jailbreaking, adversarial attacks, which are risks that the traditional security methods were not developing. So that's why you see a lot of players in that space. I would mention Lakera, which was a Swiss company. They just got acquired by a big US cybersecurity company. They were focusing on how to detect this real-time prompt injection. So if someone was trying to put like a malicious prompt in order to change the behavior of the model, how can you have it react? Credo is an interesting one here, which is more focused on this responsible AI compliance part. So how to help the companies to document and audit their AI systems for regulatory compliance. We talk a lot in Europe about the EU AI Act, for example. So this one, is really focused on the enterprise part, and we also see a lot of players, and consolidation is actually already happening. So I think out of those names, so Protect AI was acquired, Prompt Security was acquired, Lakera was acquired, and I think we'll have more coming in 2026.
Yes. Axel, you've covered this broad view, and we mentioned it earlier before. We said that Alpha Intelligence Capital, AIC, the firm that we work at, invests across the stack. Can you point out just where on this stack we have invested?
On the whole stack?
Yeah.
Sure. Okay, so starting from the bottom. So we've done one deal in the compute layer in the AI accelerators, which is called Kornami, which is a bit different in the way that they're doing something which is called fully homomorphic encryption, which is how can you run those models on hardware whereby the model and the data is directly encrypted so that there is no risk of security or like sensitive data leaking whatsoever. Company is called Kornami and is based in the US. We've made an investment into this serverless inference that you can see here. It is a bit pixelized, but it's called Bento ML. Interestingly enough, this company just got acquired by Modular that we just talked about. On the foundation model side, we've invested into OpenAI. We've invested into a company sitting closer to this category called Adaption, which is coming from people who used to work at Cohere. Ni mentioned our investment into Yann Lequin's company, which is going to be more in video side. We've done an investment, so on the containers and orchestration, we've done two investments here. I would put a company called FlexAI and a company called Exostellar.
Yes.
Correct me if you disagree with me.
And Exostellar is about to be acquired, so that announcement is coming. By the time this podcast is released, students will have seen that publicly announced.
Good. So that's it on the so metadata lineage. That's where I would put the company doing unlearning that we just talked about, called Hirundo. On the orchestration, not so much yet. So we mentioned Modular. And so on the security part, we've done one company which is focused on a small part of this stack, which is API security. So we call it AppSec for application security, and how to provide you with a virtual hacker, basically, for when you code your API applications, basically. So we've done one deal in this space in Italy, which is called Equiksky.
And then we've
Am I
also
forgetting?
invested in a company that is the largest of what's called confidential computing. So
Oh
it's a
yeah,
software side of, if you, instead of, for example, Coronami, you are able to deploy that's fully encrypted. What if you don't require encryption, but you run on in what's called confidential computing, which is it's permission driven computing, where you can deploy your models and your prompts and etc. Without requiring encryption.
and you say that, yeah, that I think if we were to criticize this model, like we don't want to do this because they've done the work. So, but if we were to do one part maybe which would be missing here would be this idea of like data privacy, and you have
Yes.
different techniques there, confidential computing,
Yes.
federated learning, for example, which are
Data
hard to,
masking. Yep.
yeah, exactly. And so this would be, missing on this stack.
Great. Excel, thank you so much. We so appreciate the deep view that you and the breadth of which you've covered this space. I know that we're at the end of the time that I asked of you to join, beyond the end of the time. If given that our students are senior level undergrads, early master students, given that they are usually technical background, they are now learning advanced AI. If they're going to start a company, where do you think the opportunities are in this space for them to start?
That's a good question. I would say that if we retake our approach, I think that one really interesting opportunity is going to be, I think it's mostly at the deploy layer. So on this idea of orchestration, but it mingles a bit with the other stacks. I think that we're soon going to get into a situation where you have different chips, right? Different chips which work well for different workloads. You have different models, you have different architectures. So, LLM, JEPA, for example, which is the company that Yann Lequin is doing. And we're now arriving to a situation where models get updated almost in real time and can update themselves, in real time. And we don't yet have the governance and like this monitoring brick basically for handling this. So if you imagine like this, like what this would look like, it would be like a control pane, more or less, which would allow you, based on like a request, based on like an input, to direct towards like the most efficient chips, the most efficient architecture or model. And, in real time, after we'll be able to update the model based on the data that it gets from production and to retrain itself. And so it's something that we're looking to that I'm personally like looking to find. So if one of the students wants to build this, you can definitely like reach out to me.
Excel has said it here. Students, if you're building a control plane that allows you to route and evaluate and govern across models, model architecture, application, hardware, and cloud providers, know that he's actively looking. So when you've got it. Excel, any parting words for our students?
No, just I think that there's never been like a better time to either start building yourself or just like working in the startups. Like the cost of failure is just like really low now, because whatever you do, if you do this, you will learn a lot. If you work for an AI startup, or if you build something, and you will find like a cool job like afterwards, even if it doesn't work out. So yeah, don't hesitate to take the risk, and yeah, and good luck into all of your endeavors.
Thank you so much, Excel. We so deeply appreciate that. And then Excel mentions that he comes from a financial background, doesn't have a technical background, but that is I think slowly becoming very untrue, because he's vibe coding. He reads so much. I mean, he uses an LLM every single day to learn something new. And so, his background is he's now becoming very, very technical, and that's a lot of that is enabled by AI. Excel, thank you so much. We so deeply appreciate the time, insight, the expertise, the breadth and the depth. And students, if you are building a company, exactly as Excel mentioned, always feel free to reach out to him. Thank you so much, everyone. We will see
Thank
you
you.
on the next podcast in this AI Sana series.